Okay, good evening. Welcome to
MathyMath91.
MathyMath91. This is a neat problem. This one gave you a little bit of trouble this morning. It says rhombus ABCD has side length 2 and angle B is 120 degrees. Region R consists of all points inside the rhombus that are closer to vertex B than any of the other 3 vertices. What is the area of R? Interesting little problem. How are you thinking about it this morning?
Well, I left this one blank because I thought that you had a third of a circle of radius 1 coming with center B,
right?
Which would make it pi over 3, but I don't think that was a choice.
Ah, interesting. Yes, you are right. Pi over 3 is not a choice. So what made you think it was a third of a circle of radius 1?
Well, because, we did a problem where there was a triangle and we had to find all points that were 3 or less inches or something away from the triangle.
Okay. Yeah, it's interesting. That actually would have been a good choice to have on there. Why don't you draw in those circles that you think represent the area that's closest to one of the vertices?
Something like that.
So maybe it looks like that.
But then what about these?
Yeah, what's going on in the middle?
Well, I thought of a new idea.
Okay.
That you draw in these lines that these lines are parallel to these lines. And this region here is, I think, is the region that has all units, that has it's all points closer to B than any other point.
Okay, why do you think that?
Well, because the center of the circle is the same distance away, can't talk. The center of the rhombus is the same distance away from all of the vertices.
Okay, that's interesting.
Or, it actually maybe isn't.
Maybe it's not.
Because you have 4 small rhombi. The long diagonal and the short diagonal. So, that may be a problem.
Might be a problem.
So it's not really such a simple problem.
No, not at all. Not at all. Definitely not a simple problem. I mean, and I don't think we'd expect problem 20 necessarily to be a simple problem, by the way.
Yeah, but how does this, what's the region that's closer to B?
Yeah, what's the region that's closer to B? So I think that's what we got to figure out.
It definitely can't be any farther than the midpoint of the side, because then it would be, any point farther than this midpoint is going to be closer to A than to B.
Okay.
And the same goes for this here.
All right.
And then, it has to be, it has to be at least this distance away from the center of the circle.
Okay.
So this is the short diagonal and has to be half that distance or less. But that really doesn't give me a very good picture.
Yeah, this is a tricky one. So, tell you what, why don't you do this? Let's see if we can draw a shape here. And we're going to try to first figure out the ones that are the same distance from B and D. Okay? So let's see if we can just kind of be systematic about it. Let's figure out the ones that are the same distance from B and D.
Well,
what would those be?
Those would be the ones on line CA.
Why?
Because if you drew, let's say you pick this point, if you drew a direct line from here, like this, these are all the same length, the sides.
Ah, okay.
So
the lines from B and D to the diagonal seem to be the same length. And what's the argument for that?
Because they're the same distance. These diagonals are perpendicular.
Ah, interesting. Okay. Diagonals are perpendicular. And things that are equidistant away are going to be what?
Well, they're going to be perpendicular at the closest point.
Okay. Good. So that's a great observation. Now let's move on. We've probably gone close to 5 minutes. Let's see if we can make the same observation for A and C.